Okay, let's dive into this. We ask AIs to understand our world, right? Our messy, unpredictable world. But how does a machine that's built on pure, cold logic handle situations that aren't just black and white? That's exactly what we're going to break down.
For a normal computer program, this is its comfort zone. I mean, everything boils down to a 1 or a 0, a yes or a no. Is the file on the drive? True. Is the number bigger than 10? False. It's clean, it's super simple, and it's literally the foundation of how computation was built.
And this is the real challenge, isn't it? We don't say there is a 100% chance of rain. We just say, it'll probably rain. We don't classify a patient's symptoms as definitively severe. We might say they're kind of severe. So for an AI to be genuinely intelligent, it absolutely needs a way to handle this messy, uncertain, and honestly, beautifully imprecise reality that we all live in.
So where do you even start with a problem like that? Well, you start with the most fundamental tool ever invented for dealing with chance. It's the bedrock of how we've thought about uncertainty for centuries. This is the classic approach, right? Probability theory basically gives AI a ruler to measure uncertainty. A 0.9 means something is super likely, a 0.1 means it's a real long shot. And this isn't just for flipping coins. This is the foundation for AI that's predicting stock prices, forecasting the weather, and even powering the spam filter in your email.
Now, what's really cool is how AI uses probability to learn. It uses a method inspired by what's called Bayesian thinking. And it's a surprisingly simple but incredibly powerful loop. An AI starts with a guess. Let's call it an initial belief. Then it sees new data, some new evidence. And based on that evidence, it updates its belief, becoming just a little more certain. It's exactly like how a doctor refines a diagnosis as more and more test results come in.
And this brilliant little loop is the engine inside some seriously powerful AI tools. Bayesian networks, for instance, are basically these big charts of probabilities that show how different things influence each other. They help an AI reason about chains of cause and effect, like figuring out the most likely cause of a system failure just based on a series of blinking warning lights.
But here's the catch. Probability is fantastic when you've got tons of good, clean data to work with. But what happens when you don't? What if the situation is totally new, or the evidence you have is incomplete, or it's coming from a source that's just giving you a vague hint?
And that brings us to the next level of our AI toolkit. These are the tools an AI uses when it needs to be honest and basically say, you know what? I'm not sure because I just don't have all the facts.
See, the traditional, purely probabilistic view would say that any uncertainty can and really should be squeezed into a number between 0 and 1. A lack of knowledge? Well, that just means your probabilities are stuck somewhere in the middle, like 50-50. But then a different school of thought popped up, arguing that, hey, there's a big difference between randomness and just pure ignorance. Sometimes saying, I don't know, isn't the same as saying it's a 50% chance. It's saying, I simply don't have enough information to even guess at a probability.
Let's make this really concrete. Probability tries to answer the question, how likely is it? It wants to give you a specific number. Possibility theory, though, it answers a much softer question. Is it plausible? It's not dealing with likelihood, but with what could be true given the little bit of info we have. And that's a really crucial distinction, especially for making safe, cautious decisions.
So to handle this, AI uses tools like possibility theory, which helps it reason about best-case and worst-case scenarios when the facts are thin. There's also another one called Dempster-Shafer theory, which is just brilliant at combining different pieces of evidence, these little hints, even if those hints are incomplete or maybe even conflict with each other. For example, a self-driving car might get conflicting data from its camera and its radar. This theory lets it combine those hints to make a more informed decision, even with all that uncertainty. It's a way for the AI to express how much it believes something based on the quality of the evidence it actually has.
Okay, so we've talked about randomness and we've talked about missing information, but there's a third kind of messiness in our world, the wonderful, glorious vagueness of human language. Let's see how AI tackles this.
Think about it. Standard logic is super rigid. It demands these crystal clear boundaries. If the official cutoff for tall is 6 feet, then a person who is 5 feet 11.9 inches is simply not tall. Period. End of story. But we all know that's just not how the real world works. And this is where fuzzy logic comes in, and it's such a fantastic concept. It allows for degrees of truth. So instead of a simple true or false, something can be partially true. A person who's 6'2" might be 95% tall, while someone who's 5'9" might be, say, 40% tall. This is how AI can finally start to reason with those subjective human concepts like warm, or fast, or close.
Now,
Fuzzy logic is just part of a whole family of tools for this kind of imprecision. You've got fuzzy sets for those vague concepts. You've got interval math, which lets an AI work with ranges instead of exact numbers. So it can say the probability is somewhere between 30 and 50%. And then you've got rough sets, which help an AI define a concept by kind of approximating it from messy, ambiguous data. So, let's bring all of this together. We've just built out a complete toolkit that an AI can use to reason about the real world in all its complicated, messy glory.
And here it is, the whole shebang. You've got probability, your go-to tool for problems with lots of data, where you can actually put a number on the risk. Then you have possibility and belief theories for when the evidence is patchy or you're just relying on expert hints. And finally, you have the whole fuzzy and rough set family for when you're dealing with vague human language and imprecise measurements. The real secret to smart AI isn't finding one magic tool. It's knowing which tool to pull out of the box for which kind of messiness.
So at the end of the day, the crucial point is this. Advanced AI reasoning is moving way beyond simple calculation. It's learning to weigh evidence like a detective, to consider what's plausible like a strategist, and to understand vague concepts just like we do. It's learning to embrace the ambiguity of the real world, not just try to ignore it.
And that leaves us with a pretty fascinating thought to chew on. Human decision-making is, well, it's complex. It's often guided by gut feelings, intuition, and years of experience. So as AIs master this entire toolkit of rational thinking, systematically weighing every single probability, every possibility, every fuzzy boundary, will they eventually make better, more reliable judgments than we can? It's definitely something to think about.